Hey, sixth graders. Today we are going to continue our discussions about functions and graphs. I know we've been doing it a lot, but it's really important that you understand this, or at least start to understand this as you move forward into algebra. So today we're going to talk about the slope of a line, and as we talk about slope, we're going to talk about a concept called rise over run. And when that we do that, that'll become really, really clear. So let's start by talking about the slope of something. So the word slope means how steep something is. A hill that has a steep slope, goes up, is harder to climb than one with a shallow slope, right? That's an easy climb. That's a really, really hard climb. For graphs, that is exactly the same thing. How steep is the graph? Does it go up a lot, or does it just kind of go a little bit? And so we use the slope of a graph to tell how steep it's going to be. This is something you played with in the marble activity that you did last time. You were playing with the numbers in there, and you were moving the marble track around, and you were making it go up, and you were making it go down, and sometimes you made it go kind of shallow, and sometimes you made it go really steep. And so when you were doing that, you were playing with the slope. So let's look at an example. That's a pretty medium slope. That's kind of in between. If I look at that, that's a shallower slope. And if I look at that, that's a much steeper slope. So where does this slope come from? And that one has no slope. It's just flat. So let's talk about it. Where do we get slope from? You noticed yesterday, at least I hope you noticed last time, that as you worked with these numbers, that it was the number in front of the x that determined how steep the graph might be. The higher you made this number, the steeper it went. So a 10 slope is really steep, whereas a 1/2 slope is not so steep. And I hope you noticed this as you were going along, that the higher you made the number in front of the x, the steeper the graph became. So how do we tell this? By looking at a graph. How can we find out what the slope is just by looking at the picture? And there's definitely a way to do it, and it's pretty cool. All right, so to do this, we're going to need another variable. We already have y, we already have x. I'm going to need another one. I'm going to need a variable for the slope, because the slope could be a lot of different numbers. It could be 10, it could be 1, it could be -3. There's a lot of options in there, so I'm going to need something to hold the place of it. So I'm going to call it m. M for slope. You think they call it s for slope? They don't. They call it m. I don't make the rules. I just teach them to you. So now we have three things. We have an input, which is x, we have an output, which is y, and a slope, which is m. So we could write the outline of any equation like this. Y equals mx. The slope times your input is going to equal y. And you've seen this without realizing it when you were looking at the tables of these. The higher the number in front of the x, the bigger the jumps it makes, and the steeper the graph is. But how do we do this? How do we figure out what the slope is? That's a little more complicated. So I'm going to give you some math jargon, and then we're going to actually look at it. It's going to be a lot simpler than it looks like at first. So if y equals mx, I can say that m is equal to the change in y over the change in x. Actually, it's called delta y over delta x. Ooh, fancy Greek. What does that mean? It really means the change in y divided by the change in x. Huh? Another way to put this. It's the rise over the run. Rise means how far something goes up. The y-axis goes up and down. Run is how far something goes side to side. That's the x-axis. This is actually what we do using stairs. Staircases have a run, that's how wide the stair is, and the rise is how tall up to the next stair. And what we're going to do is actually look at the stairs that are made within the graph. So rise over run is actually a really great way to do it. You could figure out the slope of a set of stairs based on using the rise over run, excuse me. We're looking for the change in y divided by the change in x. Okay, that's confusing, but it's a lot simpler when we look at a picture, I promise. Here's a coordinate graph. Here is a line. In order to find this, we're going to have to identify 2 points on this line. Now, when we do that, we want to find points that cross an intersection. I don't want to use a point like this or like this. I want to find one where it's exactly intersected. So it looks like 4, 8 is one of them. It looks like 6, 3. It looks like 2, 4. It looks like 1, 2. So there's actually kind of a pattern. It looks like it's, well, let's see what it is. So first we need to pick a point. It's best to pick the y-intercept. Now the y-intercept is the place where it crosses the y-axis. And in this case, it crosses at 0, 0. So let's pick another point. We like to pick the next point to the right. The next point to the right. We want to go to the right. So in this case, we're going to pick 3, 6. I could have also picked 2, 4. I could have also picked 1, 2. But in this case, I'm picking 3, 6. Great, I have 2 points. How do I use the rise over the run? Well, I can actually make stairs out of this. So let's look. I know that the run, in this case, is 3. It goes 3 over before I get to the next point. So it goes 1, 2, 3. Now I'm going to look for the rise. That is, how far up does it go? So the run is 3. And the rise, how far up does it go from 0 to 6? It goes up 6. So my rise is 6. So my rise is 6. My run is 3. Notice that I put the rise on top and the run on the bottom. Even though I found the run first and the rise second, I want to put the rise on top and the rise on the bottom because we're looking at the change in y, how much it goes up, over the change in x. How much does it go side to side? So I now have these 2 numbers. It goes over 3 and up 6. So I can put those in there. So m equals 6 over 3. That's the slope, 6 over 3. 6 over 3, that's a hard number for me to picture in my head. But if I do the division, if I make this into simplest form, I know that 3 goes into 6 2 times. Therefore, 6 divided by 3 is 2. 2 over 1, I could simplify, which is the same thing as 2. So the slope in this case is 2. And I can look at that because it goes over 1 and up 2, over 1 and up 2. It's going up 2 every time I go over 1. So if I'm going to write the equation for this one, I can say, remember to put it into y equals form. I know that the slope is 2, so 2 is the number that goes in front of the x. So y equals mx. If m is 2, I'm just going to put a 2 in that spot. And this is the equation for this line. This line is the equation of y equals 2x. Let's practice some more. Here's another line. This one's going to be a little bit more tricky. And I haven't given you a lot like this. I've given you some where you found it in decimal form. And decimal forms are okay. Decimal forms mean that the slope is less than 1. It's a really shallow slope. And this looks like a pretty shallow slope. But in a lot of cases, we actually want to leave it as a fraction because the fraction gives us a set of directions. Now that we have rise over run, so let's pick the y-intercept. There's 0, 0. Let's pick a point to the right of the first point. There it is. 2, 1. I'm going to pick the next one over. Now I'm going to look for the rise over run. I'm going to say, okay, it goes over by 2, and it goes up by 1. So the rise is 1, and the run is 2. So what is the slope? The slope is 1/2. Now I could call that 0.5, but 0.5 is not as useful as 1 over 2 because 1 over 2 is a set of directions. It says go up 1 and over 2. So I want to leave it as a fraction. When I put it into my equation, I want to say y equals 1/2 of x. So whatever I put in for x, I'm going to cut that in half. That's going to give me y. But this is also a description of this line. It says go up 1 over 2, up 1 over 2, up 1 over 2. Let's keep practicing. Okay, this one seems to be going down, going in the other direction. Before it was going up from left to right. Now it's going down from left to right. We've had some trouble with these, I've noticed. Some of you have gotten really stuck on ones that go down. What does that really mean? So let's look at what that really means. Let's pick a point at the intercept, 0, 0. Let's pick a point to the right. Now notice that this is point 5, and it goes down 1, so this is at negative 1. And then let's look for the rise over a run. How far does it go over? How far does it go up? Haha, up. So it goes over 5. It goes from 0 to 5. It goes up. Wait a minute. It doesn't go up. It goes down. But I have to express it in terms of it going up. So how do I tell it to go up but actually go down? Well, I tell it to go up negative 1 or to go down 1. So in this case, it's going to go down 1. Negative 1 is the rise. So the rise is negative 1. The run is 5. So when I put those together, I get a negative fraction, a negative 1/5. It's going to go down by 1/5 every time. And that's the power of having the slope in the way that it is. It's that it can go down to the negative 1/5. All right, let's keep trying. Let's keep going. In this case, my equation is going to be negative 1/5 x. Y equals negative 1/5 x. All right, let's look at another one. Aha! This one is also going down, but this one is a lot steeper than the last one. So I know it's going to be a steeper one, but I don't know what it is. So let's look. Oh, this time I didn't pick the origin. I picked a point that I wanted to. It doesn't have to be the origin. It doesn't have to be at 0. It could be all the way over here. The important part is the next point that I pick is to the right of the first point that I picked. Whoa, I picked a big, long distance. Uh-oh, this is going to be complicated. Or is it? Well, let's look. We're going to look for the rise over run. All right, so there is the run. It goes from here all the way over. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like the run is 9. And then the rise is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's see. It goes 12, but it's not going 12 up. It's going 12 down. So how to tell go in a down direction? Call it a negative. So it's going to go down by 12. So the rise over run is negative 12 over 9. Okay, so that means the slope is negative 12 over 9. That's an awkward fraction. Really key. I am not going to turn it into a mixed number. I don't want a mixed number. I want an improper fraction, but I'd like smaller numbers. I'd really like it in simplest form. I picked 2 points that were a long, long, long ways away from each other, but I could have picked points that were much closer. I could have picked this point and this point. So I want to simplify this because this one is not going to go down. It's not going to go 12 by 9 to go here. It's going to go something much smaller. So what's a number that both of these have in common? Well, I know 3 goes into both of them. So if I divide each one by 3, 12 divided by 3, that's 4. 9 divided by 3, that's 3. So my equivalent fraction is negative 4/3. And that is my direction. It says go down 4 and over 3. Down 4 and over 3. And if I started in the middle, at the middle, I would go down 4 and over 3, and I would get to that point. So since y equals mx, my equation is y equals negative 4/3 x. All right, great job. Good luck. Make sure to write your work in a fraction form and try to give us simplest form. Have fun.